Hey everyone, welcome back to Math with Mr. Antoine. I am Mr. Antoine, and today we're going to talk about the three types of solutions in systems of equations. That's the three different answers or three different styles of answers that can come out when you're dealing with systems of equations. As we're doing this, I want you to pay attention to a couple of things. One, how do the solutions look when we're dealing with the graph? How do they look graphically? All right, how do those solutions look? And then, how do the solutions look algebraically? Meaning, we're not looking at a graph just with variables and numbers. How does that look algebraically? Well, let's go into it. Okay, so let's first talk about what are the three solutions. All right, there is one solution. One solution means there's only one answer or one coordinate that can happen. Then we have no solution. No solution means that there is no answer for it. There is nothing happening where there's going to be a coordinate coming out of it. And then we have infinitely many solutions, which means not only is there one coordinate, there are infinitely many solutions that comes out of it. So those are three types of solutions that we're going to talk about. When we talk about one solution means where is that point? In matter of fact, there are two lines here, right? You see that this is one line in blue, the other line is in green. So these are two lines. When these two lines intersect, they intersect at this point right here. That point is your one solution. So one solution means it's just that one point over there. And this point is in the form of a coordinate. Okay, so there's going to be a coordinate for this. And the coordinate for this one, we'll see when we get to do it algebraically, will come out to be 2, 7. So that's going to be what a one solution is. It's just one coordinate. Now take a look at these two lines graphically. I see one blue line over here and one green line over here. These two lines do not intersect, and so they're not going to have a point where they meet each other. There's going to be any points where they interact with each other. That means there is no solution. There is no point where these two lines are going to cross or intersect each other. That's no solution. Third type of solution is infinitely many solutions. What that means is now you have your green line and your blue line. They both are on top of each other. So they're both sharing the same points. Because they have the same points, meaning there would be a point here, a point here, a point here, and they have all these points that they have in common. They have infinitely many solutions. Not one answer, not two, but of many answers that's there. That would be infinitely many solutions. Infinite means it just keeps going and going. It's just going to go on forever for it. All right, so they have infinitely many solutions. Okay, so now when we look at the one solution, here's what it looks like graphically. Now let's see what it looks like algebraically. Algebraically, when we solve this, and we've seen equations like this before, when we solve them, we're going to use the elimination method. Why? Because I can really eliminate this negative y and this positive y over here when I add these two equations together. So when I add the two equations, what I have is 5x plus a negative 3x, or 5x minus 3x, that gives me 2x. Right? And then if I take the minus y or negative y, add it with the positive y, that gives me 0y, which will then be eliminated because it just gives me 0. And that will be equal to 3 plus 1, which is going to be 4. So I have 2x is equal to 4. Divide both sides by 2. And now I get x is equal to 2. Hey, take a look at that. There goes my x value, and here goes the x value over here. X is equal to 2. And remember, the coordinate will be the x coordinate or the x value, and then the y value. So really our next step is to find out what the y value is. We know it over here, but let's see how we do it when we're solving it algebraically. You take any one of the equations. I'm just going to take the top one we had over here, and it'll be 5x minus y is equal to 3. I'm substituting my x is equal to 2 into this equation. So it will now become 5 times 2 minus y is equal to 3. Right? So now if I do the math on this, I have 5 times 2 is 10. So 10 minus y is equal to 3. minus 10 on both sides. And I now have negative y is equal to negative 7. Okay? And when I divide both sides by negative 1, I will now have y is equal to 7. So my coordinate, my x value and my y value will be x is equal to 2, y is equal to 7. The same coordinates that we have over here when we have the two lines intersecting each other. So it has one solution. Algebraically, I'm coming out with one solution. That's how the one solution looks algebraically when you solve it, all right? Here's the second type of solution, no solution. And remember, here's how it looks graphically. Remember, the two lines are really parallel to each other. They do not intersect each other. Therefore, they have no point where they intersect. No solution. Let's see how that looks algebraically. Algebraically, I have these two equations here. Negative 6x minus 2y is equal to 4, and 6x plus 2y is equal to 3. Now take a look at this before we add them. I have a negative 6x and a positive 6x. I have a negative 2y and a positive 2y. Those will be eliminated if we do the elimination method when we add the equations. So when I add these two equations together, right, that means this is now going to become 0x, which will be eliminated. And the negative 2y and the positive 2y will also become 0y. So really what I have is 0 plus 0 is equal to 4 plus 3 gives me 7. So what I really have here is 0 equal to 7. Ta-da, great, but wait a minute. 0 is not equal to 7. Mathematically, that is not true. And because we're seeing that these two are not equal to each other, that doesn't make sense. That's why there's no solution. There's no answer. We couldn't find any coordinate for this because of the fact that when we did the addition of the two equations, we found that we got two terms here that's not equal to each other. 0 is not equal to 7. That means we have no solution. So keep in mind, for it to be algebraically, when we get 0 equal to some number, when we add it, that's not a solution. Infinitely many solutions. Here's what it looks like graphically. One line on top of the other, or just the two lines, just the same top, just one on top of the other. And now here's how it looks algebraically. I have negative 12x plus 3y is equal to 15. I have a positive 12x minus 3y is equal to negative 15. If you take a look at this, very similar to the no solution, where we have these two are going to be eliminated. The x will be eliminated, the x value, and the y value will also be eliminated. And if we take a look, it looks like everything's about to be eliminated, right? Let's take a look and see what happens when we add this up. Negative 12x and positive 12x, that's going to give me 0. A negative 3y and a positive 3y and a negative 3y gives me also 0. So right now I have 0 on this side. Equal to a 15 plus a negative 15 is 0. So I have 0 is equal to 0. This is what we see when it's infinitely many solutions. You're going to have both sides. We know 0 is equal to 0. So it will have something where it's going to be 0 is equal to 0. Notice we have no x values, we have no y values, just a number equal to another number, or that same number, in this case 0 equal to 0. That is infinitely many solutions. What that means is that these coordinates, and for this particular system of equations, these coordinates, if you plug them into both of them, these coordinates will work. 0, 5, 1, 9, 2, 3, and there's so many more because it has infinitely many solutions. So what we're showing you here is that if you take these coordinates, put them into both of these equations, plug them in, you'll see it comes out true, and it's not just one solution, it is many solutions for it. So there you have it, everyone. Our three types of solutions: one solution, no solution, infinitely many solutions. Here's how it looks graphically. One solution has one point or one solution where the two lines intersect. No solutions, the two lines are parallel, they will not intersect, so we have no answer or no solution. And over here, the line being on top of each other, meaning we have infinitely many solutions. And as we look algebraically, we're seeing that there's probably a little bit of work to find out the two values, the x value and the y value. When we have that there's no solution, it's going to come out to be 0 is equal to some number, or you're going to see that it's not going to be equal to each other. And then if you have infinitely many solutions, again, they cancel each other out if we do it in using the elimination method, and you should have something like 0 is equal to 0, kind of like the same number equal to each other. There it is, everybody. I hope that was helpful. Good luck in everything that you do with mathematics. Stay doing the math. Do well. Love and peace.